Okay, this is the trolley motor right here. This used to pull empty cars back to the men and loaded cars out to the bottom of the slope. It would pick up its power from what's called a trolley cable or a trolley wire, solid bare copper wire, and that ran overhead the entire length of the mine. 250 volts of DC power. So when you started in the coal mine, first thing you were told, don't touch the trolley wire. There was a pole that used to rub the trolley wire, pick up its power from that wire, feed it down, and in turn it would run an electric motor which would power this electric locomotive. Now there was a man on the front called a motorman who ran it, another man rode on the back called a brakeman. The brakeman would couple the cars together, and he would also throw the switches when we wanted to go to another switch or another part of the mine. The car directly behind me here is called a man car or the man trip. Now this was used for transportation, and what it would do, it would bring the men in and out of the mine every day, and that's the only time it was used. You could see benches in that car. They would sit on the benches, come down, get out, and then do their day's work. At the end of the day, get back on the car and go back outside. Now the car we came down on was only built for the tours. It was not part of this mine at any time. So if anyone thinks the car we came down is uncomfortable, how about we take you out on this at the end of the tour? Quite a difference. Now alongside or under the car here, you'll see it's dug out. It's called a motor pit, a place to repair the cars like in a garage or a gas station. And that's basically all it was used for, was for repairs. If they had to make a repair to the wheels or the underside of the car, they would bring it right in this area. And there were a couple men like mechanics that made the repairs. They did the work down here because the temperature and the weather was always the same, about 50 degrees year round. So it was actually pretty comfortable to work in. Even when it was 0 outside, it was still 50 degrees. Now you wouldn't want to sit around in 50-degree temperatures, but it's a pretty comfortable climate to do your job in. You can see a chain hoist hanging there. They would raise up the cars, change wheels, bearings, axles, things like that. Get the car rolling and keep the coal coming out. That was the name of the game. Keep the production going. Right here we have a telephone used for communication within the mine and out to the surface. If you wanted to get someone on the phone, you'd come right up to the phone and turn the crank, and that would ring every bell on every phone. Now if you had 5 or 6 telephones, you might have 5 or 6 different rings. Maybe the call here was 2 bells like this. Okay, if I heard that, I would go right over and I would answer by ringing one back, pick up the earpiece, listen in here, talk right into the mouthpiece. Now these are all Western Electric Bell telephones built around 1920. Believe it or not, they still work in perfect condition today. You must remember one thing though, this is back when things were built to last. Don't have too much of that today, do we? Follow me right inside here and I'll show you some more. This is called the working face right here. And we're going to talk about what these 2 men are doing. If you look in here, you'll see 2 miners, a miner and a laborer actually, and they're drilling holes into the coal to loosen it. Now that's the only way you can loosen anthracite coal is to drill and blast it. No such thing as coming down with a pick and a shovel and picking it away. You'd only get a couple pails full because it's very hard. They drill holes about 8 feet long into the coal. They put dynamite into the holes, blasting caps into the dynamite to set it off. Then they run their wires back to a main cable, like I have right here. They hook the cable on, and they unroll the cable as they're backing out of the place, back around the curve about 150 feet so they're safe when they blast. They hook the wires up to the blasting battery, and now they're ready to blast. But before they're going to blast, the miner has to come in once more and check, make sure everybody's out of the way. And he gives a yell like this: "Fire! Fire! Fire!" That's a warning in 3 directions so nobody walks into the blast. He waits about 10 seconds after that. And that's what an actual blast would sound like. Now that's done by electric blasting caps, which is what we use today. Years ago though, they used to use fuses, different length fuses on every different explosive. So they would light them as quickly as they could and then run back and wait for the blast to take place.
Now many times one might not go off, and they would come back in, and they would be just going in there at the time when that explosion went off, and sometimes men were injured, sometimes even killed. Before that, they had black powder, very explosive, very unstable to work with, and there were many accidents and deaths as a result of that as well. So when they came out with the electric blasting caps, it was a great addition and a great safety accomplishment for the anthracite industry. After they blast, there's a lot of smoke and a lot of dust. So they have to wait about maybe a half hour, at least they should anyway. Let the smoke and the dust clear. And then the miner will come in with this lamp called a safety lamp. He would check for two kinds of gases. One is called methane, which is very explosive, comes from the formation of coal. Tasteless, odorless, lighter than air, found up near the roof. When you come into methane, the flame grows very large like you see here, which indicates methane gas. However, it will not cause an explosion with this lamp because it's specifically designed to test for methane safely. Regular match or a cigarette lighter or an open flame would cause an explosion in methane. The other gas we checked for is called carbon dioxide. The old timers had a much simpler name for it. They called it black damp. What it was air without the proper oxygen in it. Now our atmosphere contains 20.9% oxygen. This lamp will go out at about 16%. When this lamp goes out, you must immediately proceed to fresh air. Otherwise you'll be overcome and eventually fall over and die without the proper oxygen. You'll just go to sleep and never wake up. That's what will happen. Now before the safety lamp, they used to bring canaries down. If you look, we have a canary cage there. Doves, canaries, any kind of small birds that they had, because it was found to be true that the birds actually would breathe 200 times a minute more quickly than an actual human being. So they used the birds to detect for air. So if you looked up and saw the canary tipped over and fall over, you better get out pretty quick. So they were very quick to respond to bad air. Some cases, back in the 1600s, there were even records of sending dogs down on the cage of the shaft, and if the dog came out alive, they knew the air was good, and then the men would go down to work. So there were a lot of different methods, and by far, the best one is still the safety lamp. It's reliable, and it's safe. There's no batteries in it. Once it's lit and taken care of, it's literally fail-safe, and it continues to monitor and check the air throughout the whole shift of the miner. Now after they check the air, they come in, check the roof, make sure there's nothing hanging. If there's any loose pieces of coal, they're pried down with a pry bar. And then they begin to work here, breaking up some of these larger chunks, loading the coal into this machine called a chain conveyor. This scrapes the coal up into the car parked underneath, and that's how the coal is loaded. Now in many of the mines, and even in this mine some places, they would run the tracks right into the face. So as they continued to mine, they had to keep continually laying track and advancing all the time. When the conveyors came out, like they call them jalopies too, they would continue to work with these conveyors and keep adding a 7-foot section on as they advanced ahead. The closer they kept that pan line, the easier it was to load the coal. So they would work for that pan and get that pan on as quick as they could so that they could not have to throw the coal as far. These came out in the late 1930s, early 1940s, and this was better for the men, safer, made it safer for the men, and it also sped up production for the companies as well. Now after they load up all this coal again, they get ready to drill and blast once again. So they might drill and blast twice in one shift, depending on how much coal was needed. So it was an ongoing thing, drilling, blasting, putting up props, and loading the coal.